Hello, hello, my friends. Okay, so what I wanted to do with you is some um, live research on index wallets. You can kind of watch me go through this with you. I think this will be interesting to some collaborators and to those of you who haven't yet gotten to uh, grok index wallets or look at how they might behave, or maybe you haven't heard about them at all yet. So I just figured I would kind of do a brief review of index wallets, kind of like as a mechanism up to this point, and then we will we'll see if we can find out how we're wrong. I think a thing that a lot of people fail to practice is that when they do their research, they're trying to prove that it's right. And our goal here is, as fast as possible, find out that index wallets don't work, because then that saves us from uh, spending more time on it. You can't do that sort of thing with a company in quite the same way, but when it comes to uh, more pure science questions, which this is one of those, we can make a little bit of progress. So now that the day's over, it's possible to allocate some time to working on this. So what the plan is today is I'm going to give you an intro to index wallets. In case you're not familiar with it, it'll just be a really brief intro for those of you who already know it. Then we're going to I'm going to show you the wallet implementation. I'm going to show you the market/economy implementation. And what we're trying to do here, to just orient you a little bit, is that we have this game theoretic mechanism called index wallets, and we think that it has amazing properties. Let me show you preprint.indexwallets.org. So the amazing properties that we think, that's a lot of me there. Let's make me smaller, except the cookies. Okay. What we think is going on is that index wallets are a tool for funding public goods through selfish taxation. So that's kind of the headline there. If we've done this, then this is really exciting. And they also seem to have power decentralizing dynamics, or permission diffusing dynamics, or wealth equalizing dynamics. I don't really know what to call it, which is also exciting. In kind of the same way, the analogy I like to use is that in the same way that you might install wave pylons in the ocean, when those wave fronts come in and they get spread out so the energy doesn't slam against the shore, index wallets are like wave pylons for power or money or wealth. Which is, and I think, by the end of this, you'll understand how that works. And so we've proven a whole bunch of properties here that just say that, like, yes, here's your evidence that somebody gets more competitive if as wealth inequality goes up. And we've proven some properties that there's reason to fund a public good. This is the part that we're exploring in this existing simulation. In fact, there's lots of open questions that we would like to explore in this existing simulation. But first, let me just share with you, if you're not already familiar with index wallets, how index wallets work. They're really simple. Normally, when you make a payment to someone in the traditional economy, you have some wallet full of currencies. Here we're even imagining wallets that can have negative currency, but have negatively valued currency. That's not debt, but we can just think about a account that has maybe some USD and some euros and some yen in it. And normally, when you would make a payment, you would agree with the person who's receiving it. This is not the person who's receiving it. You would agree with the person who's receiving it. Like me, you would say, "Hey, would you like to be paid in USD or euro or yen, and I would say I'd prefer to be paid in USD, and then you would transfer the right amount to me. And if you didn't have enough of it, then you'd go out to the market and you would exchange some of your euro maybe for more USD so that you could pay me in my preferred currency. And what Index Wallets changes is that when you put your money into one of these bundles, into one of these Index Wallets, it requires you to pay with all of the currencies at the same time. In this case, you can see even the negative ones. And you can see that here's like a $1 payment coming out of this wallet, which is valued at $8. And so when we do this, a fraction of that whole wallet is transferred over. Okay, so that is the high level story of how index wallets work. And you might immediately then say, wait a second, doesn't that mean that if you're trying to pay me with a currency that I don't value the same, maybe I don't value yen or euro, or maybe there's someone who doesn't like Bitcoin because of its energy usage or something like this. How do I protect myself against this? And this gets us to in the concept of endorsements. And an endorsement is just to say that, like, if you agree with somebody on the value of something, then you have an endorsement of one. And it's just like trading, one-to-one with them. If you disagree with them in any capacity, let's say you value Bitcoin less than they value Bitcoin, then when they pay you, they have to pay you a little bit extra in compensation. So if you value things the same, they don't have to pay any extra when they pay you. If you value something less, then they have to pay you a little bit of extra in compensation. And technically what's going on behind the scenes is that they're just sending a bigger payment that's worth more. But now it has all these currency, it has all this currency in there that you don't think is valuable. And so they're going to send this whole thing over. But to you, because that purple part isn't valuable in your perspective, it looks like they're still just sending you the $1 that you had agreed to. So it feels more expensive for them, and it feels like you're getting what you need for you. And the number one response that people say here is, but doesn't that mean that I could just reduce my valuation of something, and then that means that people have to send me more? And yes, you can, but that's equivalent to saying, doesn't that mean I could just raise my prices and people will have to pay me more? And the answer to that is also yes, you can, but obviously, if you raise prices too much, then people are going to walk away. So that's actually where we get our funding mechanism, is that you can imagine somebody who values, let's say that one of these tokens in here is related to a public good of some sort. Let's say it's like Wikipedia. Wikipedia could mint a whole bunch of tokens for themselves related to funding, their funding for this year. And if there are multiple competing vendors, let's say there's two different supermarkets, and one of those supermarkets values the tokens that are associated with Wikipedia, then if you hold those tokens, it's going to be more affordable for you to buy from them instead of buying from their competitor who doesn't value them. And if a whole community, now they have to then go and pay somebody else, but if they employ a bunch of people in that community that also benefit from Wikipedia, or to choose a more likely public good, maybe it's their road system, the creation of their road system, or their local trail system, then and that whole community values that trail system, then it gives that company that's selling goods a reason to increase their valuation of this token. So that is that's the story behind how we get impact certificates that have some sort of value for funding public goods. And here we prove some properties that even in the case where there's someone, we call them Charlie, who has all the control over the global uh, uh, endorsement, um, meaning everybody else follows their steps. Even in that case, we can prove that there's a reason for Charlie to set a non-zero endorsement. And so that is what gives us a proof that this sort of thing can work. So that's kind of like a high level version of the story. And now what I wanted to, what we're exploring here is we're going to explore whether or not those competitive dynamics hold up. So far we have, it's pretty common in research to do your theory first, or so I've been told, to do your theory first, to do your in silico experiments afterwards. That's what we're doing now. In silico just means like simulation. And then finally to do real world experiments. For that, we'll make a little game which people can play in order to see, when people follow their best personal incentives, does this play out in the way that we expect it to? And hopefully, as part of exploring this in silico, we're going to learn what that game should look like. So let me take a second to get some water, catch my breath, and then we'll dive into this. Okay, onward. The place that we said that we were going to start is I was going to show you how wallet is implemented here. So you can see what this looks like in code. And we can actually create a kind of a simulation of these wallets in, I'm going to call these account just so that the name is different. So this is going to be a traditional account like you might have in a, this is not an index wallet, right? This would be like your crypto wallet where you have a bunch of different tokens, and then you can send those tokens one by one. And so let's just show you this. Actually, I think this needs to be of type np.nd array. And actually, I'm just going to introduce this right up front. So, because if you're familiar with Python, then you don't need me to simplify this for you. And if you're not, then you can just ignore this. So we're imagining this world, let's say 175.25, where there's a bunch of different currencies in your account. And so let's say that this is euros, and this is USD, and this is yen as our example. And let's make this my wallet. And cannot change data type for object array. Do we need to do this? np.array. What's the problem here? One sec, I'll fix this. Oh, right, I didn't subclass. Okay. So we can get rid of this and then nd array. Okay. Array. Great. So we now have this thing that we're calling account, and it's going to be kind of a facsimile of what we're going to create over here with wallet. And we have this visualization of it, which helps us see that there are 100, 75, and 25 in each of the slots of this account. So 100 euro, 75 USD and 25 yen. Now we want to make a payment function. The way that we're going to do this is we need to know an index and an amount. It's been a long day, so you're going to see a lot of mistakes, it would seem. And all that we need to do here is we need to take, the wallet itself, which is passed in automatically. So we're going to take this account, this wallet. We're going to go and get the thing at this index. We are going to, and then we're going to, let's see. Oh no, we should subtract the amount from there. And we're going to return a new account that just contains the amount in the one index that we care about. So when we do this, we get an error because we did not close the parentheses. When we do this, we get an error because we need to do this in 2 steps. So let's call this new. And maybe this needs to be done in place. Okay, so now what we're going to be returning, so just let me unpack for you what we just did. We, if we do np.zeros, then, and then let's have a account here of some length. So we have 100, 75, 25. So this is going to look just like before, except, not an account class. So this is, that account that we created. We are, then we're going to want to, there's 3 of them in there. So we're going to want to make a new array with just 3 entries, which is 3 because it's the length of the account. So there you go. And then we know that we're going to want to transfer some amount. So let's say we're going to transfer some amount of number index 1. So that was USD. And in order to do that, at index 1, we need to set it equal to the amount that we're going to transfer. So let's say the amount is 10. And so now we should see in index 1 right here, the number 10. Result new. This is going to be a new wallet. And okay. And there you go. You see that we have 10, but we still need to subtract from here because if we check what's inside of account, then you'll see that, it hasn't subtracted from 10. It's the same before as after. So we need to do account minus equals, account in whatever the index is. Let's replace it over here. Account in index minus equals the amount. And so now our new payment is coming over correct, and our account is coming over subtracted by 10. This was 65 now, and it was 75. So that's all that we're doing inside of this little piece of code. And that allows us to make a payment where we can say this automatically gets passed in because it's itself. We want to transfer the thing in number 1, that's USD, and then we want to transfer the amount, let's say 10 again, and we should see that 0, 10, 0 come through, which we do. And we should also see that my wallet is no longer has 75 here, but once again has 65, and we do. Okay, great. So we have implemented payment on our little account here. And I'm doing this in this way because I want you to get kind of like the mental model for how we're going to be thinking about how this works more generally. Obviously, like this is a extremely simplified implementation. Like in principle, everything that the Ethereum blockchain does when you do a transaction, everything that the Visa network does when you do a transaction is this, right? It says what currency and what account, what currency, and how much. Here we're making this thing called a payment. What's actually cool about this, the reason that we do all this up here, this kind of opaque stuff, is so that we can add these things together. So if this was, let's give you a wallet. And how much money do you want? Let's give you lots of money because I like you. You're going to have, I guess this is a lot. It's double what I have. That's a lot, right? And so what we can do here is we can take a look at your wallet. So that's the thing that just spit out down here, right? 200, 150. And we can actually take this payment, which is a new kind of account that we've just returned, and we can add it. So if you remember, the payment was 0, 10, 0. And if we then add that, then sure enough, you went from 100 to 110. We do this way where, like, returns an instance of itself, an instance of an account, because it ends up making a lot of our code really beautiful and easy to chain together and whatnot. You would never actually want to do this this way if you weren't just doing simulation, but we're doing simulation, so we're allowed to write beautiful, if impractical code. Okay, so you're now familiar with how accounts work. Let's review what we've covered. You have a person, and they have a bunch of different currencies that they own. They then, when they want to make a payment, they say which currency they want to spend and how much. And they have to negotiate that ahead of time with somebody, right? That's the key idea of existing transactions, is they say, I have this and I would like to pay you this. And what we're now trying to do is we're now trying to create a, in index payments, this is not how we do it. In index payments, the way we do it is, so let's just call this our wallet for now. We're going to ignore this implementation down here. The way we do it in index payments is we need to know how much the other person expects to receive. So the story that we're going to tell is that I am going to purchase from you a pizza. And that pizza is going to be in order for you to pay your employees, to pay your suppliers, you need to make at least $5 on that piece of pizza to pay yourself, right? And so this is what it is that you need to walk away with. Normally, this would be the purchasing price. So up here, the amount that is sent and the amount that you receive is the same thing. But what we're going to see is that index wallets challenge this assumption. They allow for there to be two different numbers. The number that I spend when I'm paying you, and the amount that you feel like you receive when you receive the payment. And it's the same number of units of currency in both cases, but the perceived value is different. And let me show you how that works. Okay, so we have this wallet, and we want to know how much it is worth. How much is this worth? Well, we know we have 100 units of euro. We have 75 units of USD. We have 25 units of yen. And so what we can do is we can just say the value, we call this a valuation, is going to give each of these their appropriate value. So let's say that you think that Euro is worth 1.1. In fact, let's just look this up together. So euro price is worth, 1 euro is 1.08 USD. So we're going to denominate all of this in USD for now. USD price must be 1. Yen price is going to be this. Okay. So we've got our valuation. Here we've gotten that valuation from the market, and that's fine. You can get your valuation from the market. What you'll see is that this is also permissive of a local valuation. So you can have a community that has their own valuation for things, and that's one of the things that we're wanting to test with this in silico simulation. Okay, so we've made our valuation, we have our wallet, and you'll notice that if we do wallet times valuation, then that what's called reifies the value of your account. So now you know that you have $108 worth of euro, $75 worth of USD, which of course, because it's USD, and you have just 17 cents worth of yen in your account. So you had 25 yen, but it's only worth 17. Okay, great. 17 cents. And now we want to know what's the total value of this. And we can do that by just summing. And it turns out that this operation is the exact same. So this is called a dot product. And when you take a dot product, all that it's doing is multiplying the two things together and then summing it up. But this is a lot more elegant looking than this is. Actually, you'll notice down here I changed it back to the first times the second and then add it up because I think I was trying to make it additionally explicit for people that I was collaborating with. But that's all. If you didn't know what a dot product is, now you do. First times the second, add it up. And so there was a little bit of, well, you'll see how we use this in just a second. So this is the value of your wallet. The valuation of your wallet is how much you think each of these tokens are worth. The value is how much that is worth total, given your personal valuation. Okay, great. Now when we make this transfer, what we need to do in order to make the transfer is we need to know the valuation of the person that we will be paying. So actually, let's do my valuation, right? You're buying the pizza from me. My valuation. I'm taking notes on where we are in the intro here and how we're doing on time. Okay, it's 6. We've got time. So my valuation, you're trying to pay me, and you would like to know how much you need to pay me, given your wallet, how much you need to pay me in order for me to feel like I got what I needed. And let's imagine that I have, let's see, let's start me out with a slightly different valuation here. We're going to say that I think that the US dollar is worth more than you do. And you're going to see why that matters in just a second. So once again, we can do our thing. We say wallet dot now you're looking at my valuation, and you find out that wow. So from my perspective, from the valuation of me, the pizza shop owner, you are actually richer than you previously thought, and that's of course great news for you. It means that maybe you'd be willing to spend more purchasing from me. Maybe you'd prefer to come to me over a competitor. In general, you're happy about this. Maybe you get better. Maybe it feels like to you get better prices. And so let me just show you what it takes for you to now. Well, and we can also do it the other way around before we do this. So let's say 0.9. Now, if I were to value it less, US dollar, less than you, then from my perspective, if you were to accept my valuation, then you would feel like you're poor now. And so let me just show you where this matters. Where does this matter? Well, so now what we're going to try and do is we now know the value of the wallet from my perspective, and now you want to know how much you need to send me in order for this pizza. Remember, we said that I need to get $5 in order for me to be able to pay everybody that I need to pay. So it's 5. So 5 over the value of your wallet from my perspective is 0.2. Okay, and then the final thing that we want to do is we want to multiply that by the wallet itself. So to find out, did I say 0.2? 0.02 or 2%. About 2.6% of your wallet is this right here. So we're going to send 2.62 euro, 1.96 USD, and 0.065 yen. Okay, so that right there is an index payment. We have figured out the amount that needs to be paid. This is called the need. So we said that the need is 5. We have figured out the value of your wallet from my perspective. And we figured out what proportion of my wallet, of your wallet, would need to be sent in order to give me the amount that I need. And then we have multiplied that by the all of the assets that are in your wallet in order to figure out how much of each needs to be sent. And of course, what that means, if we want to check our algebra, so this is the payment now, just like we figured out the payment from before. From before, it was, comparatively, well, I guess it's arguable whether it was simpler, but it was like conceptually simpler. You were just picking which one you're going to send. Now you're picking this kind of this bundle of all of them. This is your payment coming through. And what should be true is that from your perspective, it is, from my perspective, it should be worth 5. So let's check if it's worth 5. And sure enough, other than from rounding errors that come from float imprecision, it's worth 5. From your perspective, though, it should be worth less than 5. And the reason it should feel like to you you're paying less than 5 is because I value US dollar more than you value US dollar. And so sure enough, for you, it feels like 4.80. You kind of feel like you're getting a little bit of a deal. You feel richer when you buy from me versus when you buy from a competitor. And you'll see that dynamic is really critical to the way that index wallets work. Okay, great. So you now understand, that's all the math that we have to do in order to understand index wallets. That's what you'll see that, for example, this, just like I said, can be replaced with S dot valuation. And it's the same math, so that's just what we did right up there. And index is doing exactly this. It's saying what's the amount that is expected to be received. So then you say, how much is that worth? You call that value function. And that's what this is doing here. You then take that amount divided by that value function. So this part, and you multiply it by the wallet itself, right? This wallet itself. Remember I said that this first argument, just as up here, the first argument was account. Down here, the first argument is itself. And that will give you a new object, just like before when we return an account object, we're going to return this thing called an index object, which just looks like which is just one of these. It's just a payment with a bunch of stuff in it. And so let's go ahead and do that. We can make a wallet. Actually, instead of deleting all this, why don't we just reuse it to check that our little derivation here was correct. So instead of making this an MB array, we'll make this oh no, this can be an MB array. This is an MB array. And so before we got this result, and now what we expect to happen is we should be able to do wallet dot index. This is just like building a payment. In fact, believe it or not, these two are the same function. And so we're just going to say index. We could call it a payment. We could call this method payment instead if we wanted to. Let's see, we need to know, what are the arguments here? We need to know valuation and then the amount. So that's my valuation. And then the amount we called the need. And what we would expect is it's the same. And sure enough, apart from the first word is different, sure enough, the content here is the same. I think we could do something like this, and we could find out that, yes, it's true that all of the currencies in here, in this old way of doing it, is the same as the currencies in this way of doing it. Okay, great. So you now understand index wallets and how to use the API here. Oh, maybe like something that's funny and surprising is that, can you chain these? Oh, no, you cannot chain them. But you can chain them if you do this. You need to give explicit order of operations. Just to show you a hint that they're the same operation, if you do valuation, and then need, then quantity is not defined. Target quantity amount. Oh. I think that looks like the same to me. So I think we're just suffering from some let's see. Well, we can just check if those are the same, and then we can check if calling index is the same as calling that's funny. I make you this promise that they're the same, and then I guess they're not, or they're subtly different. I mean to say print. Well, unless I don't understand how to compare numbers, those certainly look the same to me. They're probably different they're probably just barely different. Like some floating point imprecision. And we could probably be dot all close. So this is just checking that they're similar to one another, and sure enough, they're similar to one another. So yeah, it's a floating point error. For some people, thinking, the reason that we have this in here is because for some people, thinking through what index wallets are doing is easier from this perspective, and you can kind of see why. We can imagine that there's some extra amount that needs to be paid, that you need to pay me, or some extra discount that I need to give you, if we have these like two different valuations. That's what these are. These are valuations, just like this and this. And so that means you either get a little bit of a discount, you can think of it, or you have to pay a little bit of a premium. And that's going to be added to the amount. So if it's a discount, then it's this will be a negative value. If it's a premium, it will be a positive value, and it gets added to the amount. And then, just like before, we figure out the index that should be passed. So that's kind of the value of this thing from the perspective of the person who's sending it. But it turns out that I guess it's somewhat non-trivial to prove that these are actually the same function. And you should know that I say it was somewhat non-trivial because somebody else who's competent proved it, not me. So thank you, Will. Cool. So you now understand how to use wallets and index wallets. And let's now move on. We can clear out our code here. And actually, let's write up. Oops. That should be. Let's write up what our plan is. So what's our plan? Well, so we have all these claims that we make about index wallets over here. And what we would like to do is we would like to show that those properties that we show over here, for example, power equalizing dynamics, or we call them inverse wealth effects. It's like the Matthew effect, but the rich get richer slower. The public goods funding mechanisms, the voluntary taxation. We would like to demonstrate all of these. But what we want to start with is just a subset of all of those. And kind of like if you talk to people who think about this a lot, then the most interesting property to them is the ability for the system to have once it has achieved a set valuation for some community, then that valuation kind of like stables out, and then it stays steady after a certain amount of time. So that's what we would like to show, kind of in the same way that if you have a swimming pool and or a small tub and you shake it about, you can get like these like unevenness, but then eventually gravity settles it out. And we'd like to show a similar property here. And so that's going to be the first step in the research process here, is that we want to see that property. I'm super exhausted today. I don't really know why I'm so tired. I guess it is kind of late, but I might need to take a short break. 1 second. Okay. Took a little break and threw a jacket on because I got the window open, so I have high oxygen content. And let's continue. So where we left off is that we're going to write up the plan here. And one of the things that, so there's like potentially a lot of code that there's a lot of code that I've worked on, but it shouldn't be too hard to explain, in the same way that, it took a while to find this concise of a representation of the thing, but it's really not that hard to explain. In just 20 minutes or so, we got there. What we're trying to show is that property of the steady state. And once we have the steady state, in talking and just thinking about it, it should make sense that we're going to achieve this steady state. You've got two players. They are transacting with one another. They see they see that they have different valuations, which means that either there's a discount or there's a premium. In the case of a discount, then it's going to attract new customers. In the case of a premium, then it's going to repel customers because it's going to feel like the price is higher. And that's where we get all of our dynamics for public goods funding. Okay, so what does that mean for us? Where I'm trying to think about how to drop you into this with me. I think that the key idea to get is this one right here. Let's draw a little picture. So we're imagining that this is a single currency economy, and we're making the height of the line equivalent to the value of some some valuation for that currency. And what we should notice is that this person over here, they have a higher valuation. And so if they approach this person, they're going to feel like, wait a second, this feels expensive. Because they don't value this token as much as I value this token. But this person is maybe going to be like, can I budge? And they're going to try to budge their valuation to try and get this customer, maybe because there's a competitor. And they would love to get this. They would love to, this person is trying to decide whether they're going to buy from this person or from this person. This person maybe would increase their valuation a little bit, but let's say that, it's just not possible for anybody down here to change their valuation, which means that this person eventually also lowers their valuation, and this person lowers their valuation too. Because they have somebody that's coming in and paying them. So this is where we think we get the steady state from. It's kind of like it's like this wave propagating in the wave pool. And maybe this person buys from this person isn't able to change their valuation because they buy from the same vendor. So we have these are the suppliers, let's say, to the pizza shops. The pizza shops would like to have a higher valuation if they could, because it would mean that this person would prefer to buy from them, but they can't because there's their supply chain doesn't support that. Okay. So that's the context that we step into, and now we need to encode this. The way that we think about encoding this is we have a product. So this would be like a pizza. Pizza are, what are the units? Let's say slices. And yes, they are discrete, which is the default. So all we mean by discrete is that you can't buy in this world. You can't buy half a slice of pizza. You can buy half a gallon of gas, but you can't buy half a slice of pizza. Okay, so we have created our product. We now need to create our, wait, I might be on version number 1, and we need to go all the way down to version number. So demand, valuation, player, offer, receives a product. Great. So, we don't have product in here. Let's go grab product. This has a new name. So there's demand, there's valuation, there is player, there is offer. Great. And we should be able to still make our little pizza here. Okay, so we have our product called pizza. And we are going to work our way up to a market where we might have 2 pizza shops. And those pizza shops have some ingredients. So they have some pepperoni, and they have some dough, and they have some sauce, tomatoes, let's say, and so on. And they need to buy each of those from a different vendor. And then they have, the hungry mouth over here. And the person who is buying this pizza, well, they have some set of valuations in their index wallet that they have set. And what we want to see is that in this economy, when you go out to buy the pizza, these valuations, if they start out really different, what was it? 1.1, 1.011, and 0.0065, something like this. If they start out different like this, then let's say this is 2, then what we expect is over time these equilibrate and have like a shared common valuation between them. So that is what we're working towards. And so to do that, let's create a player here. This is the consumer of pizza. And they're going to need a valuation. Let's go and steal our valuation from over here. What did we say? It's going to be this. So there's that. Was that the valuation we were using before? It doesn't really matter, but let's go look up the yen again. Oh, that was pretty close. Okay, so there's our consumer. We want another player called the and then let's also have a supermarket. Let's have the supermarket match the pizza shop. So the consumer is so let's actually do it the other way around. So we want the consumer to be like, the consumer values something, USD in this case, more than either of the pizza shops. We're going to have 2 pizza shops now, pizza shop 1 and 2. They're going to be competing with one another, and they're going to keep their valuations nice and low to match the supermarket that they buy from. This is the valuation of the supermarket. Does the player not have a wallet? I feel like the player should have a wallet. Yeah. The player does not have a wallet, but the player should probably have a wallet. So let's also add that to our player. And we're going to set everybody up with our classic 100, 75, 25. Great. So now our players are here. If we get the wallet of this consumer, then we can get an index to the pizza shop 1 valuation. Let's figure out first how much is the consumer worth to the pizza shop 1 valuation. Oh, that's probably because when I reinitialized it. Okay, great. So according to pizza shop number 1, the consumer is worth 1,765. If we look at it from the consumer's perspective, they're worth like double that. So they are really bummed about this haircut that they're taking. If we get the index payment, so let's imagine that the need that the pizza shop has, this is the amount that they need to make in order to remain profitable, keep the lights on, buy the requisite materials from the supermarket, etc., is 5. 5. You can denominate this in any currency you want. It makes the coming up with how to say this kind of funny, but let's call it $5. Then the amount that the consumer needs to pay is this. And from the consumer's perspective, that is worth $7. So they feel like it's a bummer. Let's imagine for a second that pizza shop number 2 comes along and has a valuation of 1.5. Well, then if we print this for pizza shop number 1, it's still 7.12. But if we print this for pizza shop number 2, we will have to reinitialize pizza shop number 2. If we print this for pizza shop number 2, as we've done here, then it's only $5. So because pizza shop number 2 is closer to the valuation of the consumer, it feels cheaper. And so the consumer might prefer to purchase from pizza shop number 2 because they have this higher valuation. But what that means is that when the pizza shop goes to buy their goods, so let's say their cost of goods was $4 when they go to the supermarket. So when they do that, pizza shop 1.wallet.index. So they're going to go to the supermarket and they're going to buy $4 worth of goods from the supermarket's perspective. Then that is going to be worth shop 1.valuation. Am I missing anything here? Well, we can print this out. That's going to be worth, of course, 4 for pizza shop number 1 because they share valuations here to here. But for pizza shop number 2, let's go edit this to pizza shop 2 and to 2. For pizza shop number 2 is going to feel like 4.85. So they've gotten a new customer, probably, that they wouldn't have gotten otherwise, but it's also cost them some of their profit margin. And so you can see how there's an equilibrating effect that we would expect to see there. Okay, so this is what we're hoping to show. And in order to show this, let's think about how this equilibration works, what we're imagining. I need to stop saying equilibration. What we're imagining is it just sounds equilibration. It's like the meaning is falling off of the word. What we're imagining is that there's going to be a process by which the customer, all customers, are going to go, I'd like to buy some pizza. And like, I really like pizza. Or maybe they're like, I kind of like pizza. And they buy more pizza if the prices are better. So they're going to be looking around, looking to buy some pizza, and they're going to look at each of the different available pizza shops, and they're going to say that one's the best deal for me, and they're going to pick from the one that's cheapest. For now, we're going to ignore. This is just an in silico experiment, so we're imagining there's like one marketplace in which they're buying all their pizza. There are two pizza shops right next to each other. Okay, so that is what we're trying to show. And so what that means, I really hate object-oriented programming, which you would not know even how much of it I do. So what does that mean? Well, it means that we need, we're going to have these ideas of things called offers and these ideas of things called orders. And an order is an offer is easy to explain. An offer is when a pizza shop comes along. Do we have a special thing for vendors? I can't remember. No. Do we have one down here? Oh, we do. The sales. One of the things about Jupyter Notebooks is like you do so many iterations of the code, you aren't sure which one you should be paying attention to. So here's our vendor. I think we don't need I think we don't need a separate thing here. So we have our vendor. I like how the vendor is purely identified by their is that by their valuation or by their wallet? The player. Oh, it's their valuation. I guess that's better. You're not just your wallet. You are also what you value. Okay, so, which in some sense, not to be too like romantic about it, is the whole point here is that we're trying to embed the capacity for people's expression of their values, preferences, and beliefs to become manifest in their economic environments. Okay. So we have a pizza shop, and they are going to make an offer. Let's go and build an offer. So the signature on the offer is that we need a player. We have the player. We need a product. We know that is pizza. We need we need to know the need. Remember, we said that was going to be 5. And we need to know the supply. How much pizza do they have to sell? Let's say it's 15. Product, pizza. Great. Let's make that pretty. So we now have a shape for the offer. Oh, I don't want that there. I want that there. Boo. Great. So we have 15 pizzas available at 5 each. That is the offer on the table. And so now what we would like to do is we would like to look at the orders. So an order, unlike an offer, doesn't map exactly onto the term. An order here is like almost think of it as a standing order. It's as though I were to walk around with a little, like if you've ever played SimCity and they have the thing that pops up over their head that says what they're hungry for. They want a hamburger. Then that's a little bit like what an order is. It says what it is that the person wants. So let's go grab our consumer. They're interested in pizza. And then we need to answer the question, how much do they want it? They have a demand. I struggled a lot with how to represent this demand because it's so there is quite a bit of criticism of economics as a field for oversimplifying market dynamics. For example, by saying that it is controlled by the intersection of supply and demand curves. That's the equilibrium price, right? And the reason that it's criticized for good reason. We know, of course, that there are instances where it fails. For example, with luxury goods, and it has a certain kind of like callous logic to it, which is another thing that people argue or complain about. And there is some question about whether the notion of a demand curve is very meaningful. So let's see if we can make for you a demand curve. So what does it take? It just takes you don't need an argument. You need what's going on? There's no attribute product. Oh, well, that would explain it. Here, let's try this. I don't know what this is going to do. Return s.plot, px.line. I think that should work. Oh, hash.product, s dot. So this isn't needed anymore. Where else does it say product? Oh, that would be why product was being passed in here. Which we do. So is a demand curve let's see, which way? Okay. Okay, so we're going to say that the demand for pizza has some shape, and we're going to return to I think there's already a ripper on product, so great. And we should be able to plot that. And so what we're showing here is that this is the pizza demand. And this is one possible pizza demand curve, which is saying that which is saying that as the price goes up, the demand for pizza goes down over here. And we can put in a different curve. I think it's just let's say that the demand is just constant. So we say no matter what the price is, this person wait a second. Is my demand curve backwards here? Because it is backwards. That's funny. Mm-hmm. Maybe I just had that backwards. So if we have fixed demand, no matter the price, we have perfect inelasticity of demand. Then no matter the price, we just want 4 pizzas. So let me talk a little bit about this choice, because it is well, actually this should be quantity. Price versus quantity, and let's fix that. Okay. So this choice, these are like, I debated a whole bunch how to do this. One possibility was that I was going to just give each person a fixed quantity demanded, but obviously that doesn't make sense, and like it doesn't account for potential economies of scale. So if in other words, a supplier would have no reason to produce more of a good if your demand curve looks like this. In other words, like you just want 3 bananas, let's say. And if somebody offered you a 4th banana, you'd be like, I'm not willing to pay anymore. And if somebody offered you only 2 bananas, you'd be like, I still want 3 bananas, even if they were $1 million. So really is not a realistic assumption at all. So I think that the value of this demand curve is that it steps us in a direction of closer to realism. If you were to do this like in a more realistic fashion, what would you do? Okay, so what's the optimal way to do this? Well, the challenge with this, of course, is that like you need to create something like general intelligence in order to actually model how these things should work. So, you know, for example, people don't want to eat pizza every single day of their life. They want to have some variety, and so that means that your demand function should be a function of prior action, should be a function of what people ate yesterday, and it should be a function of proximity. It should be a function of and availability, and so on. And so, one of the gifts that economics gives to us is like the abstraction layer. It says like up to this point, it's economics, and from and beyond that point, it is it's no longer economics. It's something more. Maybe it's psychology, or it's behavioral economics, or whatever. But we don't try and inspect it. Having spent a little bit of time thinking about this, the first time I thought through this, that was where I landed. Was that like, we're going to give each person some individual demand curves, and then we'll use that in order to figure this out. I actually think that in our initial experiments here, we should just keep those. We should just give them a fixed demand curve. So here, where it's like quantity is linear with respect to quantity is perfectly vertical with respect unperturbed with respect to price. So I think that's where we're going to start with most of these players. In fact, let's just set it up like that. So we're going to set up our pizza demand is going to be 1 piece of pizza per turn. A turn is like a day. Our pizza shop is going to want, they're just going to want 2 ingredients. They're going to want they're just going to want ingredients. So ingredients demand 4. I guess that means we need the supermarket to sell the product called pizza ingredients. And so that should be product pizza ingredients. Those are discrete. And they want, 2 per day. Lambda x is it is a function. So here's a normal function that takes in x and returns x plus 5. And lambda is just another way to do exactly that. So both of these are exactly the same. And we can test that by getting rid of this and say putting in 5. And we can do this. I'll just show you that this is actually, that's 5. So I'm just showing you this in case you're not sure what's going on with this thing. In this case, we're literally just returning the number 2. So, but these are pretty useful. Use lambdas all over the place. Okay, so pizza ingredients demand is 1. And then the supermarket, or pizza ingredients demand is 2. And then the supermarket, 2 per day. Supermarket is going to have, what does supermarket buy? They're going to buy produce. Demand, obviously this is like a very simplified market. And produce demand, and that should be 10 per day. Okay, great. Oops, I think I actually needed this. Yeah, and we can also do produce. Product. Produce. So there's our produce demand. There's our produce. Of 10. Okay, great. And so now that we have these, we can build our offers. And our offers, our orders. So once again, our orders are like those little things that float above the head of the NPC. And they require you need to know who the customer is that wants this thing. So in the case of the consumer, it's the consumer. In the case of the pizza shop, they're putting in an order for pizza ingredients. In the case of the supermarket, they're putting in an order for the produce. And because we've said that our demand is for a particular product, why don't we just go ahead and get rid of this to get rid of the redundancy, and then this can be demand.product, right? So we get that for free. And let's put in so let's go ahead and build those. That's going to be customer is going to be pizza shop. They want pizza ingredients. Yeah, I think it's fine. I was going to say that we could even get rid of the notion of an order at all and have demand be something that has a product and has a customer. That's better, right? What do we need this for? So this should be customer. And that is going to be of type player. product. I love type annotations in Python. I don't even like use MyPy or anything that warns me. The customer that wants the product. I just love that I can look at it and be like, what was it I was supposed to pass in here? Cool. So that means that building these up is now going to be easy. This is going to be the consumer. This is going to be the pizza shop. And this is going to be the supermarket. Let's see, what is this? Does this render? We don't have a pizza shop? We should. We have two pizza shops. So it's going to be pizza shop 1. And it's going to be pizza shop 2. Now, you'll see here that we're doing all this manually so that you can get a sense for what's going on in the background. In reality, we'll define a demand graph that says these are all the people that want these sorts of things and how much, and these are all the people that want these sorts of things and how much, and so on. And there'll be lots of different demand in the market, and then there will be offers. Okay. Cool. Now what do we do? Okay, so we're getting rid of this notion of orders. No, we're getting rid of this notion of offers. We still have product object has no attribute product. Okay, so you can go away. Orders can go away. What is happening? Oh, we got rid of order. We now only have offers. Okay, let's undo our deletion here. We only have offers. Okay, great. And you can go. So things are looking good. Now we can, this was me checking that some code worked as I expected. I think we'll need this in just a second. So now what we can do is we can define the market. In reality, we'll probably have something that says add demand, market dot add demand, and then we'll do everything that we did up here, and we'll add, and within the add demand function, it'll do something like, say, something like demand.append, and then it'll be demand, and then this will have its args and A1, A2, A3, like so. But until then, the choice that I've made, I don't know if it's the right choice. yeah, until then, what is the right paradigm to think about this? What I've done here is we're passing in just the vendors and the customers. With the idea being that I don't think that's right. I was going to build up, an object like called a vendor object. Maybe it would take in a demand function or a demand object, and it would take in a offers object, and then you'd think in terms of a vendor and what they want. I think that's wrong. I think instead we're going to say something like offers. No. Do we have the thing called offers? Yes. And demands. This is going to be type demand. This is going to be a type offer. Okay. And now, more or less, these need to be reordered. So let's grab our doc string because we are good, thoughtful developers. Offers. And it helps to spell things correctly. S.demands. Demands. Okay. And so then the list of vendors we will be able to get with, so just ignore all this for now. The list of vendors we will be able to get with vendors are offer.vendor, what does offer call it? Yeah, offer.vendor for offer in s.offers and s.customers is going to be simply demand.customer for demand in s.customer. Demands. Demand.customer for demand in s.demands. Demand.customer. Let's check. That is what it is called. Demand.customer. Great. Okay. And that means that all of this can go. We don't need to know. Well, I guess we could still do this line. So s.players is, and then this is where we do that whole player for player in, and then we just unpack vendors and customers. Oh boy, I hit a button. Star. And that's what I was testing up here is like if you normally go 0 to 5, let's do it into a list, then you get 0, 1, 2, 3, 4. Does this just work or does it give a range? Yeah. So normally that's what you get. If you were to then, or here we can put this in a list like so. But if you put this little star in front of it, okay, this is getting a little. So you can see here we have this list inside of another list, and it creates a nested list. That's normally what you would want. But in this case, we're trying to create we're trying to kind of unpack that list. So range, let's do up to 3. So here we now have 2 nested lists, and one of the things that we can do is we can just put this little star up front of it, and that will merge the 2 in one big list. And that's what we're doing here is we want to get all the players, and so we are merging the 2 into one big list. And what are we doing here? We don't even need to do that. We can just do this. Okay, great. And let us document the offers available in the market. the demands from customers in the market. Okay. And then once we do that, what's the next thing that we want to do? We want to compute interactions. So this is actually, I don't know what needs to go here. We should ask ChatGPT. This is going to be an interactions, a list of all possible interactions. So let me just show you this. This is all imagined interactions. So let's imagine a story where we have, this is a really simple story. All that we need to do here is, because there is there are two pizza shops and there's one consumer. Okay. So this pizza shop can either go and buy from this consumer. I have that backwards. This consumer can either go and buy from this pizza shop or can buy from this pizza shop. And the decision criteria that we're using is the consumer is interested in spending the minimum amount of money. So we're talking about competitive pressures applied to pizza shops until they lower their prices. So on every turn, essentially, the pizza shop makes an offer to the world, and then the consumer emits some demand. And then in the market, what we do when we do our interactions graph is we say, okay, imagine the consumer buys from pizza shop number one. What is the total price? So let's say it's, what did we say? $5. And let's imagine now that the consumer buys from pizza shop number two. This is now $4 because remember, pizza shop number two was more friendly to the consumer, had a higher valuation, a valuation closer to what the consumer's valuation was. And so in this world, we first generate this. This is called the interactions. And then after we have generated all possible interactions, we go through and we say, okay, so for this pizza demand that the consumer has, the winning one is going to be this one. So that happens right here, and that's the transaction that takes place. And you might say, isn't it really inefficient to go through and check all possible interactions? And to that, I say, we have to check all possible interactions because we need to know, the consumer has to go out and look and see where they can possibly buy their goods from. So we have to. Okay, so do you buy that argument? So in order to do this, then okay, so we are. This is how we do it, I guess. Oh no, I reloaded the page. That's funny. I think though I got it here. I did not. Give me this, please. And we're going to subclass from data frame. And let's check that we can just use this like a normal pandas data frame. The way we'd normally do that is something like this. Exactly one argument, the type to instantiate. Oh, okay. ChatGPT has failed us. What is going on with my copy here? Oh. You got to use new when you are doing it with pandas. I'm sorry, with NumPy. But it didn't occur to me that maybe pandas is already fine at this. So yeah. Okay, works. Great. Well, that's astoundingly easy. I don't know why it's giving me this error. What does this say? Sales. Product. Right. Forgot about that. I mean, we're making great progress. So it's 7:30 now. I could do with a little bit of food and water, and then I'll come back and we'll try and see if I can show you the functioning interactions method. All possible interactions between all possible vendors. In this case, thankfully, we don't have very many. I mean, in fact, we have so few. Maybe I can demo it right here. So offers is just going to be and they need to figure out their need. Remember, we've just decided that it's 5 for them. They'll figure that out when they do they have to emit their, and they can have a lot if they want. Let's do, who cares? Okay, great. And then they also need to get this. There, it's the exact same offer in terms of their needs. It's just going to be different because their valuations are different. Then there is the supermarket is offering this. These are called pizza ingredients, and their need, I don't know, is I think we might cause problems if it's too high. So let's do, their need is 3, and yeah, we're doing 10, 1e to the 10. I mean, we just don't care. Right now, supply is really not pertinent. I consider not even putting it in here. And then the supermarket is buying from God, basically. We're just not going to put them in there. And so that means that these are our offers, or these are our demands. So pizza demand, produce demand. Oh, we don't have the availability for the pizza so they do need to buy from God. Okay, so God. Then we're gonna have a player whose name is God. Okay, hold on. I think I need to go and get some food. I'll be right back. Let's just keep going for a second more. I want to see what this looks like. Okay, so the player God. What kind of valuation does God have? God is going to have the same valuation as everybody else. Oh, look at this. We have this type we were using for valuations. I guess we can do that. So the standard valuation is going to be this. Let's say. And the special, oh, no, this is the standard valuation. And the special valuation is going to be this one for this player. Okay, and that means that we can give you special, and we can use standard, standard, and standard. Okay, and I suppose God can go here, player, and standard. Okay, now we have God. God, I suppose, should make an offer. This is the produce offer. Offer God produce. What does God need? And how much does God have? Let's even give God a little bit more. Look at that. God has lots of produce on offer. Okay. So we have our produce demand. Now we get to do our produce offer. Our offers, various offers. So that was this, 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 and this. Great. I think that is right. Let me just, these should be offers, and these should be demands. Great. That looks right. Once again, I think in the end, these will be generated by a demand graph, but or really, yeah. So you'll have your demand graph, and then the demand graph will help vendors figure out what offers to make. Speaking of vendors, could this have been vendor and would have worked just as fine? So we have player. Let's see. Player and wallet. So if I go and put you up there, I get rid of you. We're no longer equipping our player with that. Vendor now inherits from player, subclasses player. It no longer needs these attributes because we have decided to do things another way. Did that matter? Kind of amazingly, it does not need to know orders or offers. It does need to know wallet, just like before. Okay. I suppose super net valuation wallet is in order. Great. Okay. Do you have any oh, this is accepts interactions. I mean, this is a class method. Is it a class method or is it a static? What are they called? It's a standalone function, but you want to keep it in the class because it's semantically related. Yep. Okay, that's great. That's what we had. It's a nice annotation because, like, just when you saw me there, say, did we use any, like, do we use any of these attributes in here? You can see that you can easily tell that we don't. And so you don't even have to pass the little self argument here, which is nice. Okay. So we're going to get to this in just a second, but I think that means that for offer in vendor.offers, what's the problem here? For offer in vendor.offers, colon. Now this can be vendor. Vendors are just a type of player, and everything else should work the same. Great. And now that we have our market, why don't we calculate the interactions? There shouldn't be many of them. It's going to fail. Market is not defined. Market is definitely not defined. This does not need to be a class method. It can be a static method. Okay. So the issue is for offer in offers. Yeah, this is like a weird. Maybe I'm trying to be too fancy with the syntax here, but for offer in. Oh, offer in. Oh. Okay. That will incomplete input. For offer in. Okay, just give me the damn. What do you mean incomplete input? Oh, fuck. Oops. Sorry. It's always so helpful even when I put the wrong thing in. Okay. It's honestly some pretty impressive programming, the fact that you can highlight either within the thing or outside of it. That's one of the things you notice when you start to try and build. front ends. Oh, duh. Let's just say okay. Now market is initialized, and now we deal with errors. Many errors. Offer in. We don't have orders anymore. We have demands. Offer.demand. Demand.product for demand. ns.demand. Order. Demand.customer. Order is demand. Order is demand. Okay. And now we missed one. Demand. We missed another one. Quantity. Oops. Demand.demand. So when you know you're doing things right. Okay. Interactions object has no attribute append. Right. Okay. So what this comes down to is that I should be building up a list, and I didn't. And so ChatGPT is going to tell me that what I need to do is I should probably do Bink like so, and then I should do interactions. And then, great. So that worked, except I don't have, why don't we have? Because we need columns. And this should be split. And that should be customer, vendor, total, price, payment, product, quantity, price, need. Okay. Right. You. Okay. There we go. Let's see what it recommended. Yeah. Data frames are great if you already have the data structure built, but they're so annoying when you don't yet have them built. I can't tell you how much I'm still not certain how to use data frames. Like, it's a conversation for another day, but they're almost useful. Almost useful. Okay. So look at that. There is the valuation. Well, I think we've actually put in here are the customers. So I think if we do, the good news is that are we able to do this still, or has app been deprecated? IAT? Oops, sorry. IAT. Oh, okay. player. And so that means that we should be able to get the wallet, say, on this player. Player object has no attribute wallet. They are certainly supposed to have an attribute called wallet. Let's see. Maybe. Player object has no attribute wallet. Porque. What I'm trying to confirm is that it's it definitely has the attribute wallet. Did I spell wallet wrong? Okay, well, it's there. Great. So, and then that means that at here, we should have a type of vendor. Yeah, okay, fine. The first two were customer demands, consumer demands. Here we are at 3. Nice. Okay. So what this is telling us is that this customer here, the one with this valuation, I guess that's our consumer because they have this special valuation, is looking to buy from this vendor. We could make all this a lot easier to think about if we if we gave these players like names. Okay, we'll do it. I hate this because then later on when you do your like large scale simulation, then you always get tempted to like come up with a random name generator, and it's lots of wasted time. And you could just be using like you're not going to care about names when you actually get to scale, but it's useful in the early kind of like testing stage. So let's do that. Name. So this would be name. Layer. Players. Starting wallet balance. Okay. So that means we need to rewrite this. This should be called customer. I don't like that we called them consumer. It sounds so degrading, you know? Pizza. This place is called Space Pizza. And this place is called Rustic Corner. And this this pizza or this supermarket is called who do we want to name drop here? I think Walmart. And God, if you didn't know, is obviously Vishnu. That was the God I've been referring to all this time. Vishnu? Yeah. The one that I'm really familiar with, Vishnu. Oh, shoot. We should probably name. Well, for one, we should probably use our parameter here. And then, great. We return name. Do we need to know any of this other stuff? No, we don't. Yeah, okay, fine. We need to know the valuation. And that means, okay, customer has this valuation. Space Pizza has this valuation. Rustic Corner. Great. Nice. Okay. Those, these are going to become a problem when we have lots of different tokens in there. But for now, with just 3, it's not too bad. So in theory, what this has done is it's gone through all possible meaningful pairings between someone who wants something, who has some demand, and someone who is offering something, who has some supply, who has some offer. And it's figured out, it said like, okay, these are the this customer wants to buy pizza and you are offering pizza. Great. You can be friends now. Let's check out what your need is. Your need is 5 for this customer. For this customer, that need is going to, that total price is going to come out to $7.12. And at that price, they're only going to buy 1 piece of pizza. If this were, remember that we have locked ourselves in, our demand, all of our demand, our pizza demand, our produce demand, etc., is locked in to what was it? Just a fixed quantity, independent of price. And so because of that, by the way, don't Jupyter notebooks just make you feel super powerful? It's really fun to be able to pop out those sorts of visualizations of things and these graphs just on a whim. So we compute this massive table of 5 entries. And now we want to see, who does the customer choose? So far, this is going really well. I think this all looks right. I guess we could check one of those. So let's take pizza offer and consumer. I think we called their variable name. And we just want to check the index to pizza offer.valuation.value from the perspective of consumer valuation. And what we expect to see is 7.128. And what we instead see, valuation, is an error because we can't spell. Offer has no attribute valuation. Pizza offer dot vendor. Oh, and then index missing 1. Oh, yeah, need is 5. Yep, that's right. And I guess if we were actually if we were going to write this in the same way that we probably wrote it down here, it would actually be pizza demand dot customer there and there, and same thing. So that's a good sign. It's computing the same price here as it is here. And I guess we can scope out our next steps when we come back. Goodbye. Okay, onward. I've been having a nice little break. Look, I got some dates. Importantly, not pitted. There's nothing worse than pitted dates, you know? Or dry and flavorless. It's like, why do they pit I don't understand. It's not like grapes where it's hard to get the pit out of there and crunch on it. And it's not even like watermelon where you can kind of like eat around it, but you spit them out of your mouth, but maybe it's a little fun. It's like the easiest thing ever. It's more like a peach. Imagine if they sold pitted peaches and then you'd get it and it would be dry. It's sad. It's sad. It's a severe strategic and tactical mistake. Anyway, we were going to figure out the interactions between these things. And I was very excited because it worked. It came through kind of like how we expected it. Whoa, what just happened? We deleted the thing. Oops. Interactions. I guess I could do 0. Oh, no, I think I can do at 0 payment. And I also want to check that the type is what I expect here. Unhashable type wallet. Either good news or bad news. Let's see. Let's try this. And 3. Okay. Index. Great. It's an index wallet. Okay. Lovely stuff. So we figured out all the interactions. The next thing that we need to do is we need to well, right now in vendor, we have this function which gets the sales back for a particular vendor. Wait a second. Vendor equals. Yeah, I mean, no, this cannot be a static method, but that does give me an idea. I don't think that we should do that over there. I'll show you where we're going with this. Hold on. Give me just a second. We're going to put this in here. We're going to need to pass in vendor, which is of type vendor. And there's probably needs the vendor, the interactions graph table for this step. I don't know what you call it a step, but so let me show you what we're working towards. So I'll do it in here still. So we've done that thing where we've now paired up all the different customers with vendors. And now we want to pick the purchases that the customer is going to make. So that entails basically 2 steps. The first is filtering down to, well, hold on, let's think. To give you context for what the high level of what we're trying to do is, the customer has we've imagined a world where all possible things happen, and then the customer has chosen one particular path. They've decided to purchase from vendor A or from vendor B, and in order for that to happen, we have had to search through all the possible interactions from customers to this particular vendor. No, from all possible customers, all possible purchases, payments that pertain to this vendor, meaning that not only for the vendor itself. So if there's a Space Pizza, not just the Space Pizza, not just the people who could have possibly purchased from Space Pizza, but the people who in general wanted to purchase pizza. and Space Pizza is a competitor in that market. So that's the first thing that we do. In pandas, that's as simple as product equals, let's grab our pizza shop 1. So we would say, well, no, pizza offer 1. So pizza offer 1 dot product. And so that should only give us back an error. Self.com is locked a key. Is this not a real pizza? Okay. Interactions dot locate. What is going on? I thought that oh boy. You know what? I wonder if spelling will kill me. I wonder if there is a function called product. There it is. That's so funny. Okay. So because there's a function called product, we need to do this. There we go. Which means we need to do this. And there are all the instances of all the the total opportunities for a customer to purchase pizza. So we're going to do that. Then what are we going to do? Okay, what's the next step? Then we're going to somehow pick between these. So we're going to sort values by price, I think. There is no difference here, but I think that would normally work, right? Data pd.data frame with oops. Okay. Is it row? Data. Okay. Yeah. And it's automatically sorted. So three were given. How do you reverse? I swear, when I put in a thing like this, I don't want it to do all that stuff. I just want it to give me the like shortest answer it can right away. Sort of df dot sort values by ascending equals false. What? That's what I just tried. Huh. It must be doing something internally to... Normally you would think that would work, but... Okay. Okay, so we do that. No, what we do is we get all of the interactions. So let's call this, these are the sales. And I think this is maybe what sales is doing. Possible sales. And then we take possible sales and we get something out of it. Dot. Oh, if we get the minimum price, and that should equal okay. And then that should give us only the ones that are equal to the minimum price. In this case, we still have 2. And this is the point where it's important to put in some randomness, because we don't always, like, imagine that systematically customer space pizza comes before rustic corner, because that's how it's entered in. We're going to want to randomize this. So randomize index order pandas. Ah, that's cool. So I did not know you could do that. So if we run this a couple times, we should see that they're switching spaces sometimes. Yeah. Okay. So then, oh no, it's not first. It's head 1. Why is it not first? I don't even remember. What does first do? We shouldn't waste time on this. It should have been called first. Based on a specific time offset. It's like, I don't know. Clearly, the person that was making this was using it for some sort of time analysis, time series analysis, and they made first, and then they were like, crap, what are we going to call the first couple things? And we'll call it head, because that's what Linux That's the Linux command. Okay. So this gives us our this gives us the sale that was made. Now, how do we want to use this? Now we want to oh, this doesn't work that way anymore. No, so now we do this. So it's going to be something like this. Vendor.product. And then that's going to give us the, well, that's fine. What did we call it down here? And then we get this. What is this about? Yeah. Okay. I think it's a mistake to do this here. We're going to do that here. So whenever we compute interactions, we're going to randomly shuffle everything. So it's going to be kind of annoying. Frac equals 1. Sample sample, frac equals 1. And what we just want to test is that we get back 9, not that we get back. Oh, well, let's shuffle one more time. Hold on. We want to shuffle that way we get back 9. No, 2. What the fuck? How are there so many 9s? I'm getting really bad luck. Okay, we want to test that we get back 6, not that we get back 9. So what do we get back? Ah, right. It got rearranged, but index 5. I guess I could have just ran it. I would have seen that the index was different. Great. So as long as we don't change the order, that's great. That's great. Okay. So now we're going to randomly shuffle the interactions. We don't need to reset the index. And we are cooking. So we order this, We are not doing this anymore. We're just grabbing head. Just grabbing some head. Winner.vendor equals vendor. I see how this was doing it. It was doing it kind of the other way around. I think this is fine. And then if winner.vendor equals vendor, then we do all this. Total plus equals winner.need.value. And we need to do this for each for offer in nope. Vendors don't have the attribute offers. Okay, where do we get our offers from? Well, we could do or yeah, see, this was the argument. Remember when we had vendor and customer up here? The downside of doing that as the arguments is the downside of doing that as the arguments is it doesn't really it's hard to teach somebody how to vendors and players overlap. Vendors and customers overlap. So you would want to make sure you handle those duplicates nicely. You could just pass in all players. And then you could figure out, if the player is of type vendor, add them to the vendor list. And then that would mean that you would need to initialize your vendors with their offers. We don't want to do that though, because we want our vendors to be able to emit offers. Okay, so we can't do that. That means this is why object-oriented programming sucks. It's like by far the dominant paradigm in Python. It's lovely to be able to do, for example, like as you saw up here, you can do these, really beautiful object inheritance and I forgot we did that. Object inheritance and returning an index type, which is a subclass of this, but it has the attribute send, which allows you to make the payment from customer to vendor, all that stuff. And I can show you some other code that's just like, if you massage it for long enough, you can get gorgeous APIs with lots of chaining and whatnot. Now, a lot of that stuff, like in Haskell, you would do like some sort of what they call monads, but apparently they're not really monads, which allows you to do lots of chaining because it's way more functional. But here we just have to contend with, okay, the market has offers and demands. That seems fine. That seems like a reasonable way to fit those things together, which just means that we need to figure out which sales, which offers does this vendor have? And the only thing really to worry about is that we have to go and we have to look it up. And who knows how much inefficiency it adds, but the problem is I often try and get the code right the first time so that I don't have to come back. Probably just would be better off just saying something like, for offer in, offer in, okay, no longer a static method. S.offers if offer for offer in S.offers if offer dot vendor equals vendor. And that should do the trick. And then what is this deal? I was going to like put the winner index in there, and then I was going to do the final transaction. You know, there's probably, okay, I will bet there's a way to do this. I'd like to get all the sales in from this data frame. Here's how you know that something is a sale. 1, in the product category, the price is the minimum price, and the let's rearrange this so it doesn't get confused. Sample frac equals 1. And the interaction is the earliest one, highest up in the list, not necessarily the first lowest index. And so group by product. Just gonna wait. It's fine. Oh. Oh, my brain is quitting on me. We want what does this mean? What? to as JSON. Ugh, what's the issue here?
Or do you have more for me too? Oh yeah, go do that.
I swear to you, ChatGPT is dumb. Okay, we're gonna do this step by step. That's right, it doesn't show you fucking. I just hate group bys. They're useless. Like, why? No. Well, think I'm too tired to keep going. It's annoying. Oh, let's try it. It's so useless. It's hilarious. It's like, this is probably a bad idea from a performance perspective. Fixed it. Okay, well, it teases me to complain. All right, ChatGPT, you were right. I was wrong. So Walmart bought from God, Rustic Corner bought from Walmart, Space Pizza bought from Walmart, and the customer bought from Space Pizza. And if we were to run that again, we should be able to get a world where the customer buys from, what happened here? They bought from Space Pizza. We should be able to get a world where they bought from Rustic Corner now. Customer bought from Rustic Corner. Cool. So that seems to be working. We are now prepared to take the sales object and, by the way, isn't Pandas so cool? And like the power of Pandas is got to be tenfold now that we have ChatGPT. So we can take this and we've got our new sales object. Well, if we wanted to know sales for a particular vendor, we would just check if that vendor was in the vendor column. That's nice. Yeah, that's the way to do it. Calculate all the sales at once. Do the global updating. Yeah. Cool. And then you would just make the transfer. So we're like most of the way there. What's left? Now that we got this, I'm going to take a break and then I'm going to come back. When we come back, really, although it looks like we're in kind of a disheveled state, we're really close. So the thing that's missing here is we want we're going to want the last thing to do is that every vendor in the set is going to figure out what they need and the customers that they're likely to attract for the next round. And then you're going to play the next round, and some of those vendors are going to win the customers and some of them aren't. And that's going to affect that newly updated valuation held by the vendors is going to affect the next set of suppliers, so the Walmarts of the world. And then that's going to affect God. And we should see this kind of like shifting pattern where it's like, Walmart is going to step closer to the values of the customer after like one or two turns. But in the meantime, then that vendor might be like, oh, I can't quite afford this. So the next thing to do is vendors check there. Vendors their valuations to attract customers. Cool. That's gonna be next step. Be right back. Okay, so we are coming in for a landing. It is now 9 p.m. That should give you all the information you need to compute how long of breaks I need to take. Is this that working all day and then working the evening is that's a lot. It's a lot. So we're gonna put this into here. Look at that. It's just really unbelievable how concise that code is. It's so cool. Cool. And then what? Sales. TransAccept is easy. I'm not concerned about it. In fact, honestly, this might still work even with the changes here. What we need to do is we need to say for customers and customers for we get the interactions, we get the unique customers. Let's call this bid. So bids is going to get the offers of the vendors and give them the opportunity update their valuation. Okay. This is where things get interesting. So, oh man, it's probably not going to get done tonight, but it's going to be for vendor in SW vendors. Can you do that? Sample vendors. That'd be cool if that also worked. Let's see. Okay, so that's how you do it. That's going to be so we're going to allow them to update in random order so that there's not like a persistent bias in favor of anybody. And then we're going to say vendor dot and this is where it gets expensive. Because we could imagine a vendor well, we could take the previous interactions and And we can imagine a thing where you always kind of expect that these dates seeds are going to be like softer or like edible or something, but they are not. Yeah, let's do that. One of my favorite things to do when programming is to write a function that I have no idea how to do. And then I can just move on. So then they're going to come up with their new offers, and then they are going to I know that's opaque syntax, but now you know what it means. Add the, I guess technically. Oh, this is a good question for the webcast people. Let's go to dev. Oh yeah, we can't. Dev. You know what? That might not even work. I bet this fails. That's really funny. Should tell you a lot about me. Make up syntax, ask people about it, find out it doesn't exist. Consider deleting the cast and then realize that it will be really interesting to see what people say. They are kind of nice because they're like, they have little bits of sweetness hidden around in them. Offers.extend vendor.update blah blah blah. What else needs to happen? Vendors updated their offer and their valuation. Does the customer need to change their does the customer need to change anything? Well, eventually all players will be vendors because you'll also have it's actually a good point. All players will be vendors because some players will be vendors of labor. Okay. So maybe we should then just spend a little time with vendor.update with the recognition that it's probably soon to be deprecated. Given that it's soon to be deprecated, let's just implement it in player. True, pep, whatever. Like the proper way to write Python is you do not write S, you write self, but that's a lot of letters to be using over and over and over again. What does this require? It receives interactions and it receives that's it. Okay. that algorithm is going to be really fucking, well, let's think about it. I mean, it might not be that hard. You've got, we have perfect information. So we know that there is some space of wallets. Let's make, this is in a 2D wallet space where, this is for token A, this is for token B. Really well done. Let's put these in the corner at least. And let's see. So we'll say that these are valuations. I'm sorry, these are wallets. Next thing that we need is this player's valuation. Do it like that. And we need competitors' valuations. So like that. And so, we're going to want to use this landscape to figure out like how many customers are going to them and cut them off and basically like put this wherever we can to maximize profits. And when we do that, yeah, I mean, seems fine. We're going to have this like high dimensional landscape that we need to minimize. And this is the thing that I had spent a lot of time on trying to figure out. And I think I have like an approximate understanding of how to do that search. But now that we have the right framework for this, it's going to be easier. Cool. Let's see what ChatGPT said. I mean, this should be get the interactions that pertain to this player, even if they lost the sale to a competitor. This should be maybe it's this vendor. For simplicity, we're assuming that they don't enter new markets. Yeah. This is the thing that's hard to compute. Well, we will change our evaluation. Next time. I think for now, we did great work. It's cool. I mean, once you have update, you're there. Yeah, I mean, I think you have the framework pretty figured out. Let's get rid of this. Cool. We're getting close. We're getting really close. Yeah. Cool. All right. Thanks for coming along on the journey. We should have some pretty graphs to show in 1 or 2 more sessions.